Hello, I'm Professor Richard Little, and about 20 years ago I was lucky enough to be in Hawaii while the volcano Kilauea was erupting, and I was able to hike to the active lava flow front. This was especially exciting and meaningful to me because 201 million years ago, here in the Connecticut River Valley, this is what was happening. Lava was coming out of fissures, not big volcanoes like Hawaii, but fissures more like in Iceland. This was part of a huge volcanic outpouring as Pangaea was cracking and the Atlantic Ocean basin was starting to form. We will investigate this extremely interesting lava flow that's in our backyard. And it preserves some very interesting events. Let's take a closer look. The splitting of Pangaea caused many rift valleys as the world's continents separated to become today's familiar geography. In our part of New England, the eastern border fault developed. It can be traced from Keene to New Haven. The Rift Valley gave birth to our future. It was the beginning. Many thousands of quakes over 60 million years laid the foundation for our special spot, unique in New England. Everyone living here can thank this auspicious geologic beginning that gave rise to agriculture, industry, plus the fishing and commerce of the great Connecticut River Valley. I like to think of the Connecticut Valley as a geological sandwich. Once the Rift Valley began, sediments washed into the valley from the eastern highlands. These early layers of sand and gravel are the bottom of the sandwich and are prominently seen today at Mount Sugarloaf. Next, and this is exciting, lava extrudes along fault lines. The hot and fluid basalt lava, called fissure flows, are a huge outpouring all along the fracturing Pangaea supercontinent. In the Connecticut Valley Rift, several hundred feet of lava spilled across the early Jurassic landscape of 200 million years ago. And this lava makes the hot middle of our sandwich. And then thousands of feet of more sediment fill in to form the top. Eventually, earthquakes along the border fault tilt the whole sandwich structure downward to the east. The lava middle of this sandwich is more resistant to erosion, so the ends will wear away to lowlands, but the middle sticks up as a ridge with a cliff facing west. Because the geological layers are inclined, we can easily pass through geological history from younger to older as we head west on Route 2. You now know some of the details about the lava in the Connecticut Valley Rift and its position within the great sandwich between the sediments and the lava and the younger sediments. The lava marks the boundary, the time boundary between the Triassic period and the Jurassic. Please note that there were no big volcanoes in the old Rift Valley. Lava is volcanic, but it doesn't have to form a volcano. The lava flows are fissure flows, very much like we're seeing in the current eruptions in Iceland. There are some other interesting things that the lava flow can tell us. It can tell us something about the latitude where the Connecticut Valley was located back in this part of the Mesozoic. It can also tell us the age that the lava solidified. And it can easily tell us whether it flowed on land or into one of the many lakes that was here during this time of the Jurassic. Basaltic lava has abundant iron minerals. As the lava solidifies, the iron minerals will become magnetized by the Earth's magnetic field, and this magnetic information is geometrically linked to the Earth's latitude. Magnetic lineation is steeper at the poles and flatter at the equator. Analysis of Connecticut Valley basalts indicate a latitude of 15 to 20 degrees north. That's like central Mexico. Radioactive minerals in the Connecticut Valley basalts equal a solidification date of 201 million years ago. It was a seasonally wet and dry climate. There were many lakes. Lava flowing underwater will have pillow shapes. Here's what happens. The water chills the flow surface, but the molten rock pressure pushes through again and again, producing tube shapes, one over the other, like a pile of pillows. Lava on land will flow thicker and cool gradually, with shrinkage cracks developing, which after erosion make column shapes. In this view at Greenfield's Highland Park, you can see the exact sediment surface over which the lava flowed. Was it underwater or was it dry land? Do you see pillows or do you see columns? Now, the story of lakes and lava. Lakes were prominent features in the Mesozoic Valley. Along Route 2 at Factory Hollow, that's the Gill-Greenfield boundary, there is a prominent dangerous curve, but also some great geology exposed. The road cuts through the Rocky Mountain Ridge. There are 2 lava episodes here that total 175 feet in thickness. The first flow has obvious pillows exposed in the Route 2 road cut. There was only a short time interval between the first and the second flow, perhaps just days or weeks, because there is no weathering at the contact between the 2 flows. The second flow, exposed opposite the parking area, shows no pillows. So here, the first flow was into a lake and the second flow was on land. Now, let's head a mile away, along the same ridge, to Highland Park. The first flow at this location has no pillows. Therefore, the lake shoreline was somewhere in between these 2 sites. Now, if we look at the second flow at Highland Park, it has pillows, and yet Route 2 has no pillows. Things are reversed. There's land at Route 2 and a lake at Highland Park. The lavas record shifting lake shorelines from 201 million years ago. Basalt's iron content will oxidize to reddish colors, which look very much like the sedimentary rock Arkose. You can easily tell the difference. The basalt's red color is only on the outside. The real rock color for basalt is gray to black. Arkos, however, is reddish throughout. So not only does the lava provide a scenic ridge down the middle of our valley, it also provides important details about the position of continents in the Mesozoic and the environmental conditions right here in the valley at that time. Basalt rock is certainly not very pretty, but what stories it can record.